Hey everyone, in this video I'm going to be looking at using Bazel build to package and build a standalone executable from a project written in Python so that it can be run on the user's system without having to have Python installed. So the way that we do this is we use PIP and the Python package index. This is a standard way of installing kind of Python packages. We're going to build two applications, or very simple applications. One is using the NiceGUI library and another is using Typer. So it's a graphical user interface and a command line interface. And both of them are getting built into an executable with Bazel. And then we create our own shared Python module. And this shared Python module is used in both standalone applications. But the cool thing here is that there's no dependency between the GUI library and the command line library. Before we begin, I wanted just to point out two things. I use Basilisk quite a lot in this video, and I don't really explain what it is. So Basilisk is a way to install Bazel on the user's machine or the build machine that you're using or your development machine. So if you want to follow along, definitely check out how to install Basilisk from the Bazel website. Another thing I noticed when I was making the video is that there was one tiny error in the to-do list at the side of the video. The add module to GUI and CLI step is missing for the first couple of ones. So just keep an eye out for that, and it's going to pop in a little bit later. So without further ado, let's jump into the video. So let's jump into it. So I started out with an empty Visual Studio Code project or an empty folder structure. So now what I'm going to do is I'm just going to set up the files. I'm not going to add any code into the files. I'm just going to set the files up that we're going to be using in this project. So we'll start off by making CLI.py. This is going to be our command line interface. We're going to make another file called GUI.py. Going to be our graphical user interface. We're going to be using creating a module. So I'm going to make a new folder and call it compressor. So the module is going to be very simple. This is a Python module. It's going to have methods in it that allow us to compress a file. We pass a file into it, and then it returns another a zip file or something like that. So in here we make a file called initialization. So this marks this folder as a package for Python, and then I'm going to create a new file here. I'm just going to call it tools.py, and then we have all of the Python files that we need. So this would be a really simple kind of project. So normally what you would do, you would do import compressor. You would do from compressor import tools dot compress. So we'll do a compressing. So I have the Copilot thing from I have the Copilot thing from GitHub on, so it's helping me out a lot. So we do tools dot do it like this, dot tools import compress, and then we should be able to do something like this. Here we go. So normally we would do something like that. So we're getting the tools kind of the compress function from the tools kind of file inside of the compressor package. But basically what we want to do now is I'm just going to remove all of this code again. Just save it here. Let's set up the Bazel modules themselves, or the Bazel code that we need to be able to build and run this with Bazel. So you need to create a workspace file here at the root. So this tells us that this here is the root of the project. We need to create a build file here and the root as well. So here inside of the build file, we're going to be adding our kind of build targets or build actions that are going to be creating the executables and things like that. And here inside of the compressor, because we want the compressor module to be a standalone module that can be used and shared and individually tested and things like that, we'll make a build file inside of this as well. So now normally, or the last time that I've did a video like this, the last time I would use the workspace file to create all of these dependencies, but now I've started using the new version or the new package manager or dependency manager from Bazel. We need to it's called Bzlmod or Bazel modules. I'm not quite sure how to say it, but if you take a look at basically, so instead of putting your dependencies into the workspace file, what we do is we create a folder file called module.bazel here, and with that you can we actually have the we have a place to define our dependencies. One other thing that we need to do to get the modules.bazel, at least in the version that I've been using of Bazel, you need to create a new file called .bazelrc. So this is where we add these kind of environment variables to the to the project. So we want to add the experimental enable Bzlmod. We want to add that. So if we add these command line arguments into this RC file, these are settings that are going to be added to the build command every time that I run it. And then last, like I mentioned in the introduction, we're using Basilisk, which is a pretty cool tool that handles the Bazel executable dependency itself. So what we do is to tell Basilisk what version to use. I think we can actually use it without it, but I think it's just kind of cool to show it. You can create a dot basilisk rc file, and just make sure that I have it, basilisk rc file. So this is also a kind of a config file, and we can put use Bazel version latest last rc or latest release or release candidate or something like that. So now we have all of the files set up in our project structure. So we can just mark that off here. So the next thing that we want to do is actually make it run. We've already gone through the steps of setting up the Python module itself. So you can see that inside of our compressor file here, or Python module, there's a build file. So we can check that off the list right now. So let's move on to finishing the Python setup and the dependency setup. So if I just start by adding a little bit of code in here, like normally if you'd be writing some Python code, you could do stuff like print hello world, and you would do python cli.py here, and you get this running, and this is great. But what's going to happen if you need to deploy this into an environment where you don't know if there's a Python installation, or if there's all the package management stuff around Python and all of that stuff. So our goal here is to make a built Python version that packages the Python interpreter along with all of the environments that all of the dependencies that are needed. So let's take a quick look at the environment here. So these are the Python rules for Bazel. So if we go, we can take a look at the documentation is pretty good, and the Bzlmod support is actually in beta, which I'm finding out right now. But it does feel like the most of the environment, or most of the community, is moving over to use this. So this is what I'm using now. So here you can see. Here you can see that we can use like how to register the Python interpreter and how to install PIP dependencies using the module file, which we're going to be doing. And then at the bottom here, you can see that there's a workspace file here as well. So if you want to use the old still supported version, like this is doable. But let's just jump into it. So we have our Hello World app here. I'm going to go into modules, and I'm basically just copy pasting some of the code over from the documentation. So we define the dependency Python rules here. I'm not going to add the Python the PIP kind of extension or yet, because I just want to walk through this and show what happens if we do it like this. So we say we want to use the extension Python here from the rules. We're going to register toolchain. This is done like this: python.toolchains. So we're using Python 3.11, and we're gonna say use repo. Not 100% sure what this does, and this is just from the documentation. And then at the end here we register the toolchain. All right. So now we have Python in our environment. So if I wanted to run this through Bazel, what I need to do is I need to go into the build file and define a build target, and I do that by defining a Python binary. So we have access to Python binary now because we did the dependency here. So I'm going to say name equals CLI. Is this the Copilot, GitHub Copilot trying to help? We want to say there's a source file. Oh, and actually helped a little bit. And that's it. So now we have a Python binary here. We have something called, the binary is called CLI because this is our code here. And the source file here is the path to the file relative to the root of the project. So if I do basilisk and build, I can do / for root of the workspace, and then CLI because that's what we called it here. It's going to go and it's going to fetch all of these modules for me. It's going to download Python in this this area. You can see now that what happened here at the top is that we have the these are called convenience symlinks. Like these are the output files. So if we take a look into our output Bazel out symlink here, we have the build, and now you can see that we have a client, a CLI.exe file here, and CLI.zip file, and these are the files that actually contain our code. These are the build artifacts. But when I'm working, I normally don't want this to appear. I'm a little bit of a purist when it comes to the environment, so I like to go in here and I like to add another kind of environment variable. Which means too that we want to ignore the symlinks. So I'm going to do basilisk clean, basilisk clean. So this goes away, and then now if I run the build again, it's going to be, well, it's not going to be faster because I did a clean. It's going to be maybe a little bit faster because I don't think it needs to download things anymore. But and you can see that the symlinks are still being created. It's a little bit annoying, but yeah, let's ignore that then for a while. But I use this in my my other projects, so this is something that should work. Let me check this out really quickly, just since I'm making the point here. So these environment variables that we're using, they are actually really hard to find. There are a lot of useful things in there, but they can be incredibly difficult to figure out what's available and things like that. So yeah, all right. So looks like it doesn't work right now, but it seems to be working in my other project. Anyway, so now we have we've been able to build a Python project. So we've added Python as a dependency, but what we want to do is we want to make a little bit of a better or a more interesting kind of CLI tool. So I'm going to go in here and I'm just going to copy paste some sample code from a CLI tool called Typer. This is what I use. And basically what's happening here is that I'm importing Typer, creating an app. I define two commands. One of them is called hello and the other one is called bye. They both take in name as a string here. And then we run the app. So the important thing here is this here is a PIP kind of library. This is a module that we need. So if I run this just using regular Python, cl.py, this doesn't work. No module named Typer, because I don't have Typer installed on my machine. So I could go ahead and do pip install Typer, but I don't want to do that for my local environment, and I really don't want to do this for kind of the end user either. And this is one of my biggest motivations for using Bazel, is the getting around that. But interestingly enough, what's going to happen if we do baselisk build, we do CLI again. So now we have this this library here that's not supported, but because Python is not a compiled language, what's going to happen is that this is going to build fine. So you can see that, yeah, we created a CLI.exe and we created a Python, yeah, and we added all of the code. But if you were to run this, you're going to get an error. And this is why it's really important to have tests around your Python code if you want to do stuff like that. And if someone can fill in like what in one of the comments, like how this is done in different languages, like why can I build something now that's not actually available, I'd love to hear some good kind of justifications or reasoning for this. So but what we can do is we can do baselisk, we can do run, so we actually execute the project, the program. So we do it the same way. We just do run and CLI, and now it's going to do a build. So build tries to run, and now you can see there's no module here. There's no module find, no module named Typer. So we need to get this module as a dependency on in our build environment so that we can run this. And the way that I do this is I do this with the requirements file. I'm pretty sure there are a couple of ways to do this, but I'm gonna walk through the one that I use. I'm not super happy with it, but I'm gonna make a requirements.txt file. So this is something that Python uses for virtual environments and package management and things like that. I'm going to add the Typer module in here, and normally you could go ahead and you could create a virtual environment. So let's go ahead and do that, just using the environment here. So vn for virtual environment for Python creates a folder called .venv, and we go into the scripts folder, and under scripts there's an activate script. So you can see that I have .venv. I'm inside of this environment right now. So now that I'm in the virtual environment, and this virtual environment has installed the this dependency, I'm gonna do pip freeze, and pip freeze is going to list out basically all of the dependencies around the packages. You can see that Typer actually also uses Click, which is another library, and it also uses Colorama. So this is the stuff that we need for our these are the packages that we need to get pulled in. So now I go ahead, now that I've gotten these packages, I go in here and I create a new file called requirements.log.txt. So this is what it's called, and I put these dependencies in here. Okay, so now I have a requirements file, which we don't really use, so I can just get rid of it now. Move it to recycle bin. I have the requirements log file. So now I can go back into the Bazel modules here, and I can start registering pip and point it to this requirement requirements log file. I'm pretty sure that I'm not spelling correctly. Requirements log file, and we're gonna say we want to use these are the Python packages that we're gonna use. So let's go ahead and start adding this. And this is again just from the documentation of the Python rules. So I'm going to use the extension PIP. I'm going to do pip parse. It creates a dependency called or a package. I'm not exactly sure what this is, what is it called, but it takes in a requirements log file, and we pointed to the root of the project and requirements log.txt. So this is the file here, and then we call use repo, and you can see that these are pretty much these are really similar steps to what's happening here. We use an extension, we call a command here on the extension, and then we call use repo. And I am pretty sure this is it. So now nothing's going to happen now because we haven't really used the dependency anywhere. So here in the build file, we go and we add a line here at the top, and we say, so the package, my dependency, my dapps, this is what we created here. So it's probably called a package. The package is called my dapps, and we load it here. We load the requirements rule file and the requirements function from the rule file. So what we can do then is now inside of our binary file here, we can add a new kind of argument called dapps, and the dependency here is going to be the requirement function and typer. Yeah, so basically we're saying that the binary that we're running, the CLI binary file, it requires typer because it does here. So now once we do a build and once we run, Bazel and the Bazel Python rules actually make sure that this is there. I'm going to deactivate the virtual environment, and now I could basically just delete it. I only use the virtual environment because I need to do the pip freeze. I know there are ways to do this, and I'd love it if someone could point me to a resource where I can do this in fewer steps, but I haven't found something that works for me. So now I'm gonna do I'm gonna clear. I mean, basilisk. We know that build isn't gonna tell us anything, so we're gonna do run, and we're gonna do root package CLI. And let's see what happens now. So if we look carefully, we should be able to see it actually pulling down the package. Okay, so no such target as CLI. So this is actually a pretty easy fix. So it's a typo here. Requirement GitHub Copilot didn't help me with this. So I'm just gonna clear and run this again. So now things should work as expected. So it should download the required package, and it should now run run my command line tool. So now you can see I have the bye and hello commands here, and basically I can run my command line tool the way that I want it. So one thing to note is that by adding two dashes like this, dash, this is the way to pass in arguments to the command line tool. So if I want to do hello, and I say, so hello is the command, I'm going to say Gisli as the argument. You can see that the dash means that I'm going to be passing in arguments to the command line tool. The command is called hello, and the argument is Gisli. And if I want to do bye, I do the same thing here. So now we have a command line kind of tool that uses an external package called typer. We went through how to create the log file here, And yeah, and I think we're ready to move on to doing the. So we both finished creating the basic Bazel dependency here, and we added the CLI. So the next thing we're gonna quickly add the GUI, and then we add our own package as a dependency next. Okay, so after restarting Bazel and Visual Studio and my whole environment, I actually noticed that the if I do Bazel build, Basilisk build, it's going to build all of the things. I think at least get the dependencies and stuff like that. So I noticed that the configuration that I did earlier, the convenient symbolic links, they work now. So I'm not getting any. Kind of symbolic links right now. So it was just a matter of restarting it. But let's jump over to the next task, which is creating the graphical user interface. I'm gonna use a library that I've just found out that I think is pretty cool, called NiceGUI, nice guy. Yeah, I've used it a little bit. I'm really happy with how it works out, at least in the short term. So we're going to just take this sample code here, and we're gonna paste it into our project. And again, NiceGUI is it's an external module, so we need to add it to the requirements file. So basically, I added the requirements text file in here again just to show you. I'm not going to run through the steps again, but basically what I needed to do is I needed to add this this requirement here. This is the package that comes from pip. And I went into the virtual environment again, and I created and I ran pip freeze, and out of pip freeze came this. So you can see there are a whole bunch of packages here that are being added when we do the NiceGUI library. But we don't have to worry about that. We could delete the requirements file, but it's nice to let's just keep it. And now to be able to run it, we add another build target, which is a Py binary. Let's see, name is going to be GUI. The source is going to be GUI.py, and the dapps are going to be open requirement open NiceGUI, like so. So if everything if I've done everything correctly, I'm going to clear here, and I'm going to do basilisk run, because building isn't going to tell us anything. In this case, at least, we're going to build a run, and we're going to do root of the project and GUI. So base. Okay. Probably forgetting something here. Source. Yep, typos. Okay, now we run it, and now you can see it starts downloading all of these packages that that are defined in the requirements log file. And you'll notice that now the Python zipper is doing its thing. It's zipping all of these dependencies into a package. And now we're actually running the command line. And notice that this is actually taking quite a long time to run it. And this is something that we're going to take a look at in one of the next steps, where we actually build the executable and packages better. So here we can see that we get a little bit of a warning here. I don't know what this is, but this doesn't seem to cause any problems. So now you can see that we have a web page or a GUI for our project that says just hello NiceGUI. It runs on a local server. And if we go back here into Visual Studio, you can see that yeah, I mean, it's complaining about a couple of things, no supported web socket library and things like that. So I'm just going to do clean here, clear, and I'm going to paste in another, I'm going to put another example into this, one where we have the, where we have a button. So I'm not gonna necessarily go in and talk much about the code, but you can see that I just created a new, I have a label, hello NiceGUI, I have a button, and I bind the button to the to this event here, and then we do a notify on the UI. So let's run this again. It should go a little bit faster, but the bottleneck is always going to be taking all of these kind of files. There's probably thousands of files that are these kind of external dependencies, and we're adding them to a zip file. So and now once we run, we actually have to extract all of the files out of the zip file again. And this is all stuff that happens just behind the scenes. So let's see if this works. I'm going to take a second. Yeah, here we go. And all right, so now we have our button here. But when I press the button, nothing happens. This took me a while to actually figure out. And you can see that these warnings and errors, I think this top one here, this is just a warning, but yeah, this is a warning that we don't have to worry too much about. But the one here is for some reason the NiceGUI depends on WebSockets, but does not. So it's not enough for us just to say the requirement is NiceGUI. We also have to say, and then I'm going to go into the requirements log file, and I'm going to find WebSockets. We are also going to add the requirements WebSockets in here. I don't know why you need to be kind of specific about this dependency in particular. So I've had this a couple of times happen with when I'm using these libraries, and especially libraries or modules that have a lot of dependencies. In some cases, you need to explicitly say that there is a requirement on something, even though you wouldn't have to do it normally. So like if someone knows exactly what's going on here, I'd love to hear it. But there was just a bit of a trial and error getting this to work. But now, just by adding WebSockets here, you can see that if I press the button, here at the bottom, you're getting button was pressed. And if we take a look at our script here, you can see that something is happening here. So the last thing that I want to do here is so this was the graphical user interface. So I want to add one small thing here again. One of the things that we haven't really looked at yet, which is how to use actually use our module that we created in the beginning. So you see that we have this. We have these files here, but yeah, I'm gonna jump onto the next chapter and take a look at that next. Right. So so I added an extra step here that we're gonna do next. We have our command line interface code now, and we have our graphical user interface code now, or the GUI code now. But when we started out, we created this kind of compressor module here, which was supposed to do an action for us. So we wanted to do something like compressing a file. So what I wanted to show here is that here we've been working with these kind of Pi binaries. But inside of the compressor module here, we can create a Pi library. And the Pi library basically works the same way as these external dependencies that we've been using. So I can create a Pi library, and I'm going to call it compressor. There's a source, and I'm going to call the source tools, which I think is fine. And just like we had in the Pi binaries one, if this module here had its own dependency, we were using something custom only inside of this module here, you could do that as here. So if this were, for example, if we would have to do in that case, we would have to go in and take the dependencies here like so, and let's just say that requirement requests, for example. So if if our compressor module here uses something like request, here we go. You could do that here. So that means that your command line tool does not have a direct dependency on the request library, for example. It's only your module here, and the module or the module library here can be built as a standalone package. Okay, so but we're not gonna do that. We're just gonna keep it as simple as possible. So I'm gonna go ahead and I'm gonna do basilisk build dash dash, and then I'm gonna do compressor, and then I'm gonna do the semicolon. So so you can see that this here, I keep saying semicolon, 2 dots. These 2 dots mean that now this is the root of the package, so this is the root of the workspace, and we called it compressor. So let's just see if it builds. Okay, so successfully built. So the compressor library from the compressor module. So I'm gonna call this yeah, I think this is fine. Like, so we have a library in here, and it has the same name as the library here. Okay, so compress my file, and I'm gonna say, yeah, why not? Let's see if we can have the I'm gonna have Copilot do it. So we take in a file path and we give it an output path. We open the file path. Yeah, no, so let's not do that. This is just confusing. So I'm gonna say this is gonna be an input path and an output path, and then I'm gonna say open the input path, and I'm not going to write the whole code for this because this is just for opening the input file, and then print compressing with writing out the output file. So this is just you could do something where you use the zip module or something like that, but for our intents and purposes, compress my file function is a part of the compressor module, and it is a library that we can use. So let's jump ahead here into our the CLI tool again, and let's import our we do import compressor. Let's do from compressor import dot tools import what was the function name again? Compress my file. So we're just going to get this function here, and then we say let's just add another command here, and we call do compress, and this is going to be input file, and this is going to be output file, and then we take our function here and we call it input file and output file. So now basically what we've done, we've added our own module here that's part of this compressor module here. We've added it and made it available here. So let's try and run this again. I'm going to do run dash CLI, and let's just see what happens. So run the CLI here, and it's going to complain that there's no module named compressor, which makes sense because we haven't defined this module as a dependency. So the way to do that is we don't have to use the requirements or anything like that. In our build tool here, under the CLI pipe binary, we can add a dependency on our own package. So we can say -- for the root of the project. We say compressor dot, and then we take a look inside of the build file of the compressor here. It's called compressor. So we are creating now we're creating a dependency on the library, the Python library here. Here we go. And we run this again. Okay, let me. Let's take a quick look. So the compressor here. Okay. Oh, right. Yeah. Here we go. So I also always make this this mistake, and this is actually kind of cool because one of the really important things here, you can see that the error that we're getting is that we need to check the visibility declaration of the target, which means that by default all of these Python libraries are are only visible to I think things that are in the same package. So if I had multiple Py libraries here that do different things, I can link them together within the package. But right now we have the root package or the base package here. This is trying to use a package, and what Bazel is telling us is that no, you can't use this package because you just don't see it. You need to configure the visibility of it. So to do that, we say the visibility is set to public on this package here, and that's done like this. So we try this again, and this is actually one of the things that I think is kind of cool, because you need to be so explicit about how you connect your packages together, which just means that you can end up with cleaner code. Okay, so now you can see that we were able to compile it. So let's run the compress command and do help. Here we go. It takes an input file. So let's call it my input file and my output file. Okay, so here you can see that we have the command line interface actually taking in my input file and my output file, and you can see that it's printing out, opening the input file, compressing, writing out the output file. Okay, so now we do the same thing here for the GUI. So we can just copy this line over here, but another cool thing about this is that even though now, because our graphical user interface, the GUI, is a completely separate app, so we also need to say that so if we were to run the UI now, I'm just going to copy this here into the button command so that we have this, and let's just say input and output text files and notification. We compressed something. Okay, cool. So so if we take a look at the build file here, the binary file for the CLI tool declares the compressor module as a dependency, while the GUI does not. So you need to be explicit about saying that we want the GUI to also use the compressor module. And one thing to, even though we're doing the same thing here, one of the cool things here is that there is no dependency between the CLI tool and the GUI tool. They just share some libraries and share some versions of libraries, and the code is the same. So and this is something that I think is, this means that this can be tested in isolation, built in isolation, and deployed in isolation, which is kind of cool. And then, just for the sake of seeing if it works, we're going to run the GUI tool. And again, this takes a while because we're shipping things. And the thing that I really like about this is that now the compressor kind of module, we can also define these Py tests, if I remember correctly. Let's let the Copilot do it. So we can create tests that are then just focused on only this module. And we see here, we compressed something is the message that we're going, even though we're not actually compressing something. So you can see that, and it's printing it to the log as well. So so now we've basically added our module both to the CLI and to the GUI. And the cool thing I think here is that now you can write these really detailed and good tests that are within the compressor module. And they don't have to depend on the CLI tool or the GUI tool or anything like that. It just promotes really good kind of practices. So I'll admit that I've been in this spot for working on Bazel for a while now, and but now the next step is the one that was probably the most important to me. It's actually packaging what we have. So so let's take a look at that. Right, so now we move on to actually building the executable itself and seeing if we can use it for something practical. So inside of the Bazel RC file here, I've removed the file that removes these the symbolic links, just to show how this works. And I had to restart the Visual Studio in between. So now that I can do basilisk build. So now I'm gonna do build. I do root, and let's just start with the CLI tool. It starts by downloading everything. We've seen this a couple of times before, and shouldn't take too long. But now you can see that I have a couple of these folders here, and your kind of the file or the build artifact is going to be stored under Bazel out, fast build, and binary here. So let's open this up in the Explorer. Here we go. So I don't know if this is easy to see, but here you have a couple of files. Keep it like this. A couple of files. You have the CLI.exe and you have the CLI.zip. So I know these two are the required ones, and yeah, we don't have anything here. So what I can do now, I should be able to just open up, create a new folder here on my desktop. Here we go. I'm going to copy paste these two files. I'm going to move the CLI.exe and the CLI.zip file, and just going to run it in PowerShell here. I hope this is. So I'm under new folder. I'm going to do CLI.exe. So it takes a little while to run, but you can see that I can do compress, first path, second path. And you can see that I now have a CLI tool. All I had to do was I had to go and get the zip file, and if we take a look into that, you can see that it contains all of the packages, Click, Colorama, Typer. It has the Python installation. So this is basically the output. This is what you would deploy for your for any third party, like if you want to run this on somewhere else. So let's try the GUI here. And this takes a little bit longer to build, but it should it works the same way. We go in here, we can see that now in the same folder, if I go here again, you can see that I have the GUI file here, and I have the GUI.exe. So let's go ahead and paste this into our standalone file, and I'm pretty sure, I think we can just double click on this one because it starts a process. Again, takes a while to run. I keep talking about this because this was one of the things that was kind of limiting me from using this for a while, because if you have a command line tool, for example, you don't want to wait 5 seconds between commands. So let's see if this works. And now I have so now I have a standalone tool that I can run. called that's which is kind of cool. So basically this is the way that we do it. We build the executable, and then the easiest way, or the most basic way, is just to copy paste these two files, the GUI and the zip file, out, and then you can run it. But like I mentioned, this isn't super practical for if you're building something that you wanna use, especially if you want to use this in like as a command line tool or something that has to be done fast. So I want to show something what I do in production at my company. Yeah, let's take a look at that. So the last step, and this is something that I would love to get some feedback on, is packaging the output files themselves to be able to use them in a real environment. So like I mentioned a couple of times, having the output zipped is a little bit slow. So it took a while to figure out how not to do it. So you can see that if I basilisk build, I can give it the flag build Python zip equals false, and enable run files. So build Python zip false means that it's not going to zip the output files like it's been doing all of this, which means that we're not going to get any access to any of the runtime files, so it's not going to work. So enable run files means that it's going to copy the run files, or the files that are needed to the output directory. So let's do CLI. So we run this. And we are running it so that it should show us the outputs here. So we take a look at the output folder here under binary. So if I go in and take a look at this in the Explorer, you should see that I don't have a zip file anymore. I have this folder here. I have the executable file. I have this folder called CLI exe run files, and this contains everything that was inside of the zip file. So if I move this now over to the UI is probably still running, so let's just make a new folder here and new folder 2.1. So before it was the only thing that I had to do was just do the zip file and the CLI file, but now there is a file with no extension called CLI. I need that too, and I'm not sure what's inside of this file. So if you know what this is and I have some insight into it, I'd love to know. But now what I can do is I can do CLI.exe, and it's almost instant. So I can do compress. Yeah, so it's missing the input file here. So so doing the command, having the build Python zip as false and enable run files creates an output that yeah, an output like this. The second thing, yeah, and I actually have the let's take this out. I was going to show you this again a little bit later. Just gonna make sure that I have it. Here we go. The second thing that's really useful when we're doing this is basilisk. It's called cquery. Cquery gives us information about the target that we're building. So if we do CLI here and we do output equals files, basilisk cquery. What am I doing wrong? Here we go. Yeah, every time basilisk. Okay, so now you can see that this actually prints out a list here of files. It does an executable file, it does a zip file, and it also tells that I'm not quite sure why it's giving us this Python file here, because it's not part of the output. But what I like to do is there is a flag here called an output filter. So if I create the, if I put the output filter here, like so, right, so it's not doing anything here, but basically this means that we're only getting these 3 lines out here, so we can actually see what file is being like what is being output. So if we switch this over to GUI, it's going to do a build, and then it's going to tell us here's the GUI.exe and GUI.zip. So so what I've made, and I have a little bit of a more advanced version of this when I'm working, and you saw this a little bit earlier. So I'm defining my action here at the top. I'm defining 2 build commands. These are the commands that you saw: basilisk, build, zip file, and enable run files, and the action. And then we do the query command, cquery, don't match anything, and the action here. So we can start by running the build action here. This is going to build our target, in this case the CLI file, and then we can run the query because we know that we've already built it. We return the information that comes out of it. So this is a return object, and out of that we can decode it and split it into lines. So there's probably a whole bunch of kind of code that we could write to make this safer, but I can be pretty sure that in this case this is going to correctly split it into lines. And then here I can go ahead and I can just loop over each output artifact in the output artifacts here, and let's just print it. So I'm going to do Python packager.py. So it will build for me because I have the CLI tool here, and then it will run the query. But here you can see that just to be absolutely sure that I'm doing this correctly, I'm gonna make sure I run this again. Yeah, here we go. So you can see that it prints out the CLI file, the output file here, and then the zip file. But one thing to note here is that like it will always give you these files here. So in our case, because we're not zipping the file, you need to do a little bit of kind of scripting to get this to be right. Because if we take a look at the output folder now, if I reveal it in the Explorer here and here, so you can see that there is no zip file. So what I'm doing in my production code is that if I find this zip file here, I just change the name from the zip file over to the exe run files, and I ship that as well. I take the executable file, and then if there is an executable file, I also include this. So what we can do now is, and you could then extend this to be a build tool for your, or packaging tool for your code. And here you could take the file and you could add it to a zip file, or you could upload it to Git or something like that. So so there are a bunch of kind of options here. I'm still working on my version of it, which basically does all of this. It compiles everything into a zip file, so not to be run out of the zip file, but just as a gathering mechanism. So we gather things together, and then I've hooked it up to GitHub Actions as well. So whenever I increment the version number, which is a tag on GitHub, I run this. It will build my targets. It will collect them together and then create a new kind of release on GitHub, which is really cool. But it's still a little bit, it isn't as far along as I wanted, so I don't want to go and show it just yet. But if someone is interested in seeing the code for that, let me know, and I can make a video of that. And again, if you enjoy this, I think this is the end of this video. If you enjoyed this video and like to see something else, like leave a comment, subscribe to the channel, and or just reach out. I love talking about this stuff, and I'd love to connect with more people who do.